my pleasure to invite Professor Idris Bedirhanoğlu from Dicle University, Diyarbakır, for his presentation.
Yes.
So, yes. The title of the presentation by Professor Bedirhanoğlu is New Retrofitting Technique for Substandard Columns to Prevent Shear Compression Failure. Thank you, Professor Bedirhanoğlu.
Yes, thank you, Professor Yazgan, for your introduction. I just want to share all the screen, probably, or yes, I will share all the screen. It will be better. So everything is mixed up in my screen, I think, due to like, let me see, something happened. Can you hear me?
Yes, we can hear you, but we cannot see the screen. At the moment, it's black.
Oh, it's just freeze. My screen freeze. So let me see.
Okay. Yes, now we're seeing the Microsoft Word.
I think I lost the presentation. Let me reopen.
Okay.
Okay.
Yes, now the PowerPoint.
Yes. Fortunately, it's here. So can you see it clearly? So can I continue?
Yes, but you may start also slideshow if you like, so that we can see it easier.
Like this?
Yes, perfect.
Okay. Okay, yes, sorry, maybe it will not be a good presentation because we had it a very heavy schedule. I just back from the site earthquake from Antakya and Kahramanmaraş, and we had yesterday we had a big workshop about the earthquake with some professors from Purdue University and from Canterbury University. So I like in advance, I apologize for some mistakes can have in my presentations. And I would like to thank to Professor Ilki for inviting me for this excellent workshop. And I'm very, very sorry that I couldn't prepare very well for this workshop since I have been working on substandard RC members maybe more than 15 years. So, but we just developed a new retrofitting technique for short columns, especially particularly for short columns, but it can be applied to other substandard columns as well. So I thought it may be interesting for this workshop. That's why so suddenly I just decided to attend and I prepared something. I hope it will be helpful. So before like my content of my presentations, I want to just say some few words on recent devastating Kahramanmaraş earthquakes. So since we have been there and we survived more than 300 buildings, so I want to just say a few words to our researchers that in this workshop. So after that, I will directly move to material and method and experimental work and result, and then this discussion quickly. So where we visited during our 2 weeks duty, so you can see the points, and then now we are in Diyarbakır, and we lasted in Diyarbakır and we did a workshop yesterday. So those areas with high ground velocity actually. So our team is just last night, one of our van broken down, so we needed to fit in one van 2 people, and then I am trying to preparing my presentation for the workshop for the yesterday. So let me show you a very interesting video from the area, a recent video that it will maybe give you a rough idea instead of speaking. So if I can open it quickly, download, I just download it, yes. So this video is belong to Norda. We have been like in 27th of March, and then we will move to another city. And this is Türkoğlu. More than I think more than 50% of the collapsed buildings have already been removed. Some of those buildings are tunnel form buildings, and I think some of them collapse as well. Maybe you saw it, just the basement is there. And this is from Antakya. Many new buildings also have been collapsed, like just is code comply buildings. So we check the details, everything is almost done according to the court requirement. The concrete quality is not very bad. I surveyed one of the building. Now I am trying to do the analysis. So I don't know if we have something is going wrong with the code. So there are a lot of non-structural damage. Looks like that the too much drift so happened to the building. So maybe we need to limit the drift that the code allowed. Maybe we can like put more strict points in terms of the drift. Maybe we should consider 1% or something and put some more shear walls. Maybe it will help. After this earthquake, we saw that it is not easy to survive, even though you survive the earthquake, but all the interior walls have been collapsed. So you are not going to live in those buildings like psychologically, so mentally you will have problem. So that's why I think so code needs to be modified by considering observations from the recent earthquake. This is Hassa. So I don't want to take much your time. I'm going to close the video, but it's almost finished. And this is Elbistan. There are a lot of high-rise buildings. I don't know why they are constructing those high-rise buildings. There are a lot of gardens, so they can just construct 2-story, 1-story buildings. So it becomes kind of tradition. So every people, maybe they want to live in high-rise buildings. Yes. Our last point is Elbistan. Okay, let me quickly shift to my presentation. I would like to thanks to Oscar from PhD student from Purdue University for this video. So I will make it bigger. Yes, quick note. Sorry. Short columns, I saw from observation, short columns are quite a common failure modes. So as we observed, like visiting many cities, maybe about 10 cities. So other things that what happens, so detailing, I think, again, low strength concrete, lack of, I cannot see my presentation. Let me shift the design. Yeah, okay, now it is okay. Okay, lack of development, as Halil Sezen Hoca also talk about this, and I also observed that a lot of local failures. So the building is okay, but some points there are backlings, and then so they market these buildings as a severe damaged buildings. So the second, my point is there is non-proper structural system like soft story, lack of shear walls, proper arrangement of the vertical RC elements, and improper for foundation, and maybe lack of enough geotechnical resources. I think I can summarize like this. So as we all know, we are in a seismically active, not Antakya and Kahramanmaraş region, all the other regions. During these earthquakes, those are some small earthquakes happen all around the Turkey. So I know I'm in Diyarbakir. In Diyarbakir also we just had a small earthquake about like maybe about 4 in terms of intensity. So those are some samples from different earthquakes, like 2011 Van earthquake. You can see the, like short column shear damage, and 2018 Derbandi Khan in Iraq. You can see this short column failure, and 2023 Kahramanmaraş. So what's happened? So after we finished the design and we are doing the construction, and then they, for example, they construct some walls, and they leave a small window. So this wall keep like keep the column against moving in 2 directions. So this make the column to receive more higher shear forces than to the design. So this simple calculation show this. If the column height, for example, is like half, so it will receive like double shear forces. So in the code, Turkish seismic code, there are some points relating to short column problem, or the code considering some precautions, but as in our software or in our design, we don't know maybe where wall will be constructed. So it is not considered usually mostly it is not considered in the design, even though for new constructions. So if the engineer hopefully consider those walls and then put the reinforcement all the through height of the column, so the column may be okay during the earthquake, but this is not the case actually. Those kind of columns need to be retrofitted vitally, and as we see the shear short columns may cause severe damage to or collapse of the buildings. So shortly, FRP jacketing is most common application. You know, I also did some research on FRP retrofitting of short columns. However, may not perform well for all cases, particularly for those with shear compression failure. So my research is focused on this point. So what can we do if you consider principal stresses in 2 directions, tensile and compression? So you can improve the performance in terms of tensile forces, but what will you do for shear forces? Because shear stresses, sorry. So for shear stresses, you need some elements that can carry shear forces, not only confinement. So with FRP, you make confinement and you can increase the capacity, increase strength a little bit, but it will be limited. So now we will see from the test. So those tests of FRP retrofit specimens, you can see the reinforcement details. So let me see, yes, this region is like test region. We have only one stirrup. So this is the application and then FRP details. The testing method is like this. We lay down the specimens to make it make the test more easier, and this is the result. So we see like the higher load capacity is of course with the one with 3 layers of FRP. This one is with 2 layers of FRP, and the blue one is 1 layer of FRP. So you see there is a limited increase. There is a limited difference between those 3 different specimens with different amount of FRP. So the reason for this is basically after one point, so specimens like here, this specimen is with 3 layers of FRP, and crashing happened inside the core of the column. So that's why you cannot increase the capacity with extra layer of FRP. As I say, thanks to the confinement, maybe just a little limited amount of stress can be carried out. Our target is to show that substandard short columns can be retrofitted against shear compression stresses as well. So for this target, 4 substandard column specimens casted. 2 specimens have been retrofitted with method developed in 2015 by myself. And for the test, we applied axial load and monotonic load protocol, not cyclic load protocol. So detail of the specimen is here. Shear effective depth span ratio is 2.6 about, and the amount of we have 2 different amount of lateral reinforcement like hooks. One is like with 0.098%. The other one is we have higher amount of stirrup. We have more hooks. Actually, this one is code compliant amount of stirrup have been used in those 2 specimens. It means that we have 2 reference specimens and 2 retrofitted specimens. One is with very low amount of stirrups. The second one is have a good amount of stirrups, but because of like the failure mode, so a good amount of stirrup also may not be enough. So particularly in case of extremely low strength concrete. So this is a different point. So the
last 2 minutes.
Let me show you the details, reinforcement details. Sorry?
Last 2 minutes, please.
Oh, really? Very short. So we have 1 stirrup here. We have few stirrups here. You can see like the details, and the concrete have a lot of water to make it low strength. And this is the retrofitting technique. So we put the perforated plates and then anchored, and then we pour the concrete. Actually, this is mortar concrete. And then the testing, you can see the testing setup is similar. And measurement, a lot of measurements, so we can measurement for when you retrofit the column, it becomes difficult to take all the measurements. So this is failure, load displacement relationship. Yes, so for the column having more stirrups, like according to codes, still have the typical shear failures, but with higher amount of lateral load capacity. So let's look at the retrofitting. This one is retrofitting 1. Let me, since we have less time, I will just do the comparison. So here with this retrofitting technique, we can increase some amount of shear force. Okay. So here This one, the SO is original, the first one, and the second one, the SR, is retrofitting one, and CCRS is with higher amount of stirrups, and the other one is the retrofitted one. So you see, like just like stirrups, the higher amount of stirrups, the same amount can be gained with external retrofitting as well. So if we go discussion, here you can see maybe this picture is better. This one is with small amount of stirrup and original one, and the second original one is this one with higher amount of stirrup. This one. So we put external retrofitting with perforated steel plate together with mortar, so that amount we can increase the shear capacity. But still, with higher amount of stirrups and with external retrofitting, we just close to the flexural capacity. This one is the flexural capacity, and again, but we have the failure. So we need to increase the method, the performance of method. So I will just directly say a few words about this. With a proper precaution, again, is expansion. When we confine something, we need to consider the expansion also. So such as strengthening the corner connection, the effectiveness of the retrofitting technique will be increased. So our next step is to test some more, to do some more experimental work and increase this method to be effective against shear compression stresses as well. Thank you very much.
Thank you, Professor Bediranoğlu. It was a very comprehensive talk. We understand your university is located closest to the earthquake region. So I guess even in your campus you're able to feel some of the aftershocks, I guess. Is that correct?
Exactly. Yes, our buildings, some of our buildings, engineering faculty, and the rectorship, the building of rectorship also need to be retrofitted or demolished. So they are doing performance analysis. So we will see. And actually, the first news they announced that the earthquake happened in Diyarbakir and surroundings.
Right. Correct.
Yeah. So, and I think about 7 buildings collapsed during the first shock. And after that, this number increased, more than 20 buildings. So now, I think about I'm not exaggerating, as I heard, I think about maybe nearly 10,000 buildings marked as severe and moderate damage. So this means that thousands of buildings will be needs to be destroyed. But in the beginning of this workshop, I asked to Professor Ilki, do we have to destroy all the moderate damage or severe damage? I think no. There are a lot of buildings that can be retrofitted, just putting some shear wall and jacketing the damaged columns. So if you destroyed all the buildings, the same contractor will come and construct the same buildings. So it may also be in risk in the next earthquake. So in retrofitting, you need more advanced engineering. So maybe retrofitting maybe I think will be is a better solution. So we need to seriously consider retrofitting. And my suggestion for future that we need to think about to put some more shear walls. And of course, we will use FRP, but we need to consider some alternative retrofitting techniques as well.
Yes, thank you. Thank you for sparing the time for the workshop and sharing your observations under such difficult circumstances. Thanks a lot. Thank you.
Thank you.
And
thank you.
yes, it is really critical. Do
If
you
I
have
have
any?
some
Yes.
bad presentation, I'm sorry about that, because I
No,
am
it's yeah.
really, I'm at the university, but in hard condition. I got
Mm,
like due to maybe tiredness from sites, so
sure.
I'm not feeling very good. But I
It's
hope.
very understandable. Thank you for your attendance and sharing your presentation with us. Do we have any questions for Professor Bediranoğlu? So, if yes, Professor Roskakis.
Okay, thank you. Thank you very much for the very interesting presentation. I would like to ask you, what do you think is the main problem in your region? Since I can imagine that the base ground accelerations that you have experienced was very high. Yes or no?
Yes, first of all, hello, Professor Theodoros. I am very happy to see you here. So I will be very happy to collaborate with you. I couldn't follow all of your presentation because I was preparing my presentation. So I will be very interested in collaborating with you on those substandard columns or beam column joints. So in my region, I am in Diyarbakır now. Diyarbakır received the ground velocity in Diyarbakır here, this area, is below 20 centimeters per second. And the acceleration is under the, I think, 0.1 G. It's less than 0.1 G. So, and it means that the drift demand will be less than 1%. If I am not, if I am correct, I don't know. It should be there. So less than 1% drift shouldn't make many buildings collapse. But in my region, I know there are a lot of poor detailings, and some of the buildings that say they cut the columns. On the top of the poor detailings, extremely low strength concrete, kind of 8 megapascal, 10 megapascal, because I did hundreds of samples. We took many samples during these 20 years. So we saw that the concrete strength can be as low as about 5 megapascal, 6 megapascal, 8 megapascal. Above 10 megapascal is very good. So if we saw something like this. So on top of those things, soft story is critical, soft story. And you have soft story, you have some columns, you don't have any shear walls. The ones with shear walls are on the lift, those shear walls damage heavily damaged, but survive the building. So that's why I am thinking that definitely we need to take help from shear walls.
Yes.
Urgently, we need to add some shear walls to our buildings. So that's why I'm thinking that retrofitting will be maybe a good alternative instead of demolishing all of those buildings. But unfortunately, I saw that many people, they just escaped from their buildings. They don't want to live there, even though they have light damage because of high drift demand of the earthquake. Interior walls, all demolished. You check the building, you say this building is terrible, but there is no moderate damage to the columns, just light damage. Really, you cannot believe.
It is always the same. This is the same picture in any strong earthquake.
Yeah.
Don't worry about this, but shear walls is a good thing to, of course, to think of. But my point is for the accelerations, you should consider that you are on a plate moving towards another. So we should see the whole picture, how the whole was moving. Then we may have some answers. I don't know.
Exactly. So the other point is maybe soil, not maybe a general view of the soil condition, like in terms of geologic research, not on the top part of the crust. We need to consider deeper soil conditions and then associate with the structural type. In some places, maybe we will say we shouldn't maybe construct high-rise buildings. We will limit the number of stories, or according to this, we need to put this parameter also into our design. But definitely, if your building surviving the earthquake, okay, but still, some people say, okay, my relative's dead, but I am half dead. Why? Because I lost everything. So I cannot, some of them, their building is okay, but due to maybe higher shaking, higher drift, you know, like maybe some places are 2%, maybe more than 2% drift happen. So I think that's why I'm recommending that we should limit the drift, because always earthquake happening. It is not one times. We said, okay, we finished this earthquake. This happened just in Adıyaman 2 years ago. Like in 2020, sorry, one earthquake happened, and 2018 in Iran border, I went there as well. So always it's happening. Every few years it's happening. So that's why we are not making our buildings like robust, more stiff. Why we are not doing this? I don't understand. If I am going to construct a house for myself, so I will consider some other things rather than code requirements. So maybe actually the code suggests us the minimum one, so we can make it more stronger. Sorry, I don't want to take much more time. Thank you for considering my thoughts.
Thank you, Professor.
Discussion.
Thank you. Are there any comments we would like to get from the audience? Otherwise, we have reached to the end of their presentation session and reached the closure. Thank you for all this attendance. For me, it was a very informative workshop on a very critical topic. So the issues related to substandard buildings are vital in seismically active regions of the world, particularly for the case of developing countries. We should really work on these buildings because they are really the key to a seismically resilient world and seismically resilient regions in developing countries. It's in my mind, it's our responsibility to bring, to develop safe and resilient structures to the next generations to come. It's our responsibility, and while tackling this problem, this issue of substandard buildings is the key. I think that's the most focused point we should invest our resources on, so that we can accomplish this goal of delivering safe and resilient communities to next generations. And I thank all the speakers for presenting their research findings. It was very interesting to listen them. The presentations covered a very wide range of scope, including the assessment of the existing buildings, the utilization of high-end materials, and various observations from these last earthquakes in Turkey, in Italy, in Greece, and so all these wonderful site observations. It was very informative. Thank you for all your time and attendance to this workshop. I hope such workshops will also trigger new collaborations among the participants. So this way we will be able to to tackle this problem much more effectively. So these workshops are really wonderful to share the knowledge and also trigger new opportunities for collaboration. I hope this workshop will also create such collaboration efforts for producing even more fruitful and even more effective strategies for mitigating the risk. Well, thank you for all your time and efforts in preparing the presentations. I would like to give an applause to all our presenters. So thanks a lot for all your efforts.